When you're dealing with a t-distribution, you're often looking for the areas under one or two tails, and very often you're not looking it up in the table, although you always can. You'll probably use Excel functions that return the t-distribution for you. This little note is just to advise you to pay particular attention to what Excel gives you in those functions. Make sure you're reading the definition of those functions, that you use them correctly. Typically, we're looking at a t-distribution of some sort, where you want to know the area under the curve for a certain t value, so t, alpha risk, and v for the degree of freedom. We're all usually coloring in and thinking in terms of the area under the curve. So this might be perhaps t of 0.05 with the appropriate degree of freedom. If that's the case, then we know that the area under the curve here to the right is in fact 0.05, and that would be our risk as we go through. So this would be considered a right tail distribution. And that's the one we're typically looking at when we look at Excel type functions or things of that nature as we go through. But not all t functions are created equally. There's also the notion of the two-tail distribution, which if I draw that, we're going to end up with a t over here and a t over here, where this is t alpha over 2 for v, and this is negative t alpha over 2 for v. So we're doing a two-tailed distribution. That's what we're working on. We're interested in the area under the curve on this side and the area under the curve under this side. So if you're using an Excel function that returns a two-tailed distribution, you end up taking the alpha over 2 risk in the function as you go through. Sometimes Excel takes in alpha and it does the dividing by 2 under the covers for you. So pay very particular attention to which the distribution is giving you as you go through. It's also two other less common but available alternatives would be a negative t alpha over v. This would be considered a right-tailed. Doesn't happen as often in most functions, but it can happen. And another common one is the what's called the same t value, but this would be considered the inverse right tail. So it's another single value. So it's possible these functions will give you a series of percentages as you go through. A common one is the t inverse function. So I do a t inverse in Excel, and it asks for an alpha. If I want to get this two-tailed side, then I give it an alpha of 0.1. So if I'm expecting a 0.05 here and an 0.05 here, the sum of that would be 0.1, and I would give it a 0.1 with the appropriate v going through, and it does the division under the covers to give me that appropriate value. The problem is when you want a right tail only and you mistakenly use the t inverse and give it the alpha that you want. So if you look at the relationship here, if I wanted to use this t inverse function to get the area under the curve on the right tail, I'd have to make sure I double the percentage I give it. So even though I want the 0.05 on a right tail, I would still have to give it the 0.1 in order to determine the 0.5 on each side. So be very, very careful as you go through this. The main recommendation I make to you is whatever Excel function you choose to use to get these values, before you use it to solve a problem in your engineering or in your homework for that matter, always test your interpretation of the function to make sure it's correct. So always take the t table from your text and pick a few representative values, maybe for 0.025, which is the single tail on the 0.05 for the two-tail test, maybe with a degree of freedom of 5. Go look up the value you expect to get from that from the table so you know the correct answer. Maybe do it for a degree of freedom of 10 and get the 2.228. Repeat it for maybe the 0.05 probability, so you get the 2.015 and the 1.812. So make sure you can create this table, if you will. If you can't create this table using the Excel function, you must be using the Excel function incorrectly. So if you're using an Excel function for the t dot inverse two-tail or the t dot inverse for the one tail, or the t inverse for the inverse function. Whatever function you're choosing to use, make sure you can use it in an Excel spreadsheet to recreate this little table. If you can, then you know you're using the function correctly and you can go ahead and solve your problem. But if you can't recreate this table, chances are you're using the function wrong. If you simply use it in your homework assignment or on an engineering problem, you'll end up getting the wrong answer. You'll never actually know it because you don't know it's returning the wrong value. So use these things very, very carefully in Excel. Excel has lots of built-in functions and they're very, very powerful, but you have to make sure you're using the right one when there's multiple functions available to you.